Today we're going to take a look at properties of parallel lines. But before we continue with something new, let's take a look back at something that we have already done and confirm our skills. So take a moment and complete the questions on page 1 and page 2 of your organizer. Before we get started on properties of parallel lines, let's just take a look at our diagram of a set of parallel lines, just so that we can confirm and make sure that we understand how these parallel lines work and how they are marked off. So first thing we need to make note of are these two little arrows. These two little arrows mean that these lines are parallel, and this means that these lines will never touch and that they are always going to be that exact same distance apart. So these are what we're using to help us indicate that, again, they never touch and that they are parallel. We do, however, have a line that's cutting through on an angle. So we can see that line right here. This line is what is called a transversal. And a transversal basically tells us that this line transverses or crosses over our parallel lines or our sets of parallel lines. And where those crossovers happen, so right there and right there, these are intersections. So similar to an intersection on a roadway where two roadways cross each other, that is what we have in those two areas right there. So with a little bit of basic understanding, that should help the rest of our angle properties for parallel lines go hopefully a little bit smoother. When we're talking about alternate angles, what we're talking about are angles that are between the parallel lines but are on opposite sides of the transversal. So again, if I think of parallel line and I think of transversal, I can simply think of how these relate to each other. So if I take a look at angle A, obviously it is underneath my parallel line. So what I'm looking for in terms of its alternate angle has to be inside of this set of parallel lines or above, right? And when I think about it being on the opposite side of the transversal, I have to think of going over that transversal. So this is telling me that angle A, whatever it measures, and angle C, whatever that measures, are going to be alternates. Similarly, if I take a look at angle B, right, between my parallel lines, but what I have to look for is something that is on the opposite side of the transversal, and that congruent or same measurement angle is going to be D. So if I take a look up into my original larger version up here, and I look for angle PJM, so I find P, J, and M. So the angle I'm looking for is right there. What I have to think of is what congruent angle is going to match that angle or have the same measurement, given the fact that it is between parallel lines and on the opposite side of the transversal. So in this particular case, what I have is this angle over here. So I can say that angle PJM is congruent or the same measurement as angle FMS. So FMS. I can also say that angle QJM, so if I find that one, QJM, so right there, is going to be congruent or the same measurement as angle RMJ, that one right there. Remember, there's different ways I could write this. I could also write this as FMR or JMR. That's no problem, but I'm just choosing to go RMJ. But again, most importantly, between my parallel lines on opposite sides of my transversal. So one thing that hopefully you've realized is that with our alternate angles, what we're actually creating, or what we can look to help us, is something like a Z or a Z pattern. That's going to help us right there and there, tell us that those are the same measurements. Now for corresponding angles, what I have are angles that are on the same side of the transversal. So again, I've got to think of, there's my transversal, now I've got to be on the same side, so either left or right, and they're in the same relative position. And what the same relative position means is, that might mean that they are either above or below a parallel line. To help you out, you might have something, or think of this as being like an F pattern. And with our F pattern, that means that if the stick in the F is like the transversal, and I have something that is below the top line and below the bottom line, those would be my corresponding. So look, using that over here, I can see that angle A, because it's on the right-hand side of my transversal and below the parallel line, is going to be congruent or the same measurement as angle G, because again, it's on the right side and below the parallel line. If I take a look at angle F, it's on the right side, but it's above the parallel line, so it's going to be congruent or the same as angle B, which is also on the right side and above the parallel line. Flip to the other side of my transversal. If I look at something below, so this might be like a backwards F, I have angle D and angle H, which are going to be congruent because, again, left side of the transversal, and they are below my parallel lines. And lastly, I might have E and C are going to be congruent or the same measurement because they're on the left-hand side and above my my parallel lines. So if I take a look at my diagram back up on the top of the page, right, what I can start to do is look for some corresponding angles. So corresponding to angle QJM, just take a second, look for that, try and figure out, okay, where is QJM? So it's on the right-hand side of the transversal. It is below a parallel line. So what corresponding angle is going to match up with that? What I have is angle SMN, again, because it is on the right-hand side of my transversal and below my parallel line. If I take a look again on my top diagram for angle KJP, so here I have something that is on the left-hand side of my transversal, and it is above a parallel line. What I need to look for is something that's also on the left-hand side of my transversal and above a parallel line, so it's in the same corresponding or relative position. And what I have there is angle FMR. So again, using that F pattern to help us figure out our corresponding angle. All right, the last theory of parallel line angles that I need to work with are for interior angles. So for interior angles, what I can think of this as like a C pattern, or maybe that's better written kind of like that, right? And what this is telling me is that what I have are, again, parallel, I'm looking for parallel lines, and I'm looking for things that are on the same side of my transversal. So there's my transversal, right? I need to take a look for my parallel lines. And what I'm looking for is for items or angles that are between my parallel lines. They're on the same side of my transversal. And when I take and add those measurements together, what I'm going to get is a measurement of 180 degrees. So in example that we have here on our side, okay, we have angle A. And again, if we think of, got to be, my interior angles have to be on the right-hand side of my transversal. They have to match up and be between our parallel lines. That's telling me that angle A and angle B, when I add them together, whatever their measurements happen to be, are going to be 180 degrees. If I have, or take a look at angle C, again, now I have something that's on the left-hand side of my transversal. It is above a parallel line, so I have to look for something that's on the left-hand side of my transversal and below the parallel line that is above. So that's going to be angle D. So again, these are going to be equal to 180 degrees. So if I take a look back at my larger example from, or that's on the previous page, all right, what I can look for are angles that are going to be equal to 180 degrees. So if I take a look at angle PJM, and I think and look around in my diagram and think, okay, what angle is on the same side of the transversal as PJM and is between a set of parallel lines where PJM is also between? What I'm going to see is that angle is angle RMJ, and regardless of what those angles measure, they're going to add up to equal 180 degrees. Try very quickly finding the interior angle for QJM on your own, and we'll take a look at that when we come back. And when we also come back, take a second and try and complete or figure out all of the missing angles that you have in this diagram. Again, good suggestion. Make sure to write all of your angles right on your diagram, and then just go looking for the angle measurements after the fact. That's what I'm going to do. That's what I encourage you to do. All right, for our second interior angle, what you should have found is that angle QJM, and when you add that together with angle FMS, that's going to equal 180 degrees. Now I've gone ahead and added some of the answers to the bottom question, but I think it's probably a good idea just to make sure that and explain how I did that. So obviously one of the angles, and we're not given too many angle measurements here, we're only given that one and that one. So what I chose to do is start in the bottom corner and use a whole bunch of angle theories that I already know to help me out. So to figure this one over here, what I used is opposite. Remember, opposite angles. If I have intersecting lines, whatever is opposite the angle that I know is going to be the same measurement. And again, this is going to be a great opportunity for you to take something like a playing card or a ruler or a post-it note and start covering up bits and pieces of your shape to make it easier to see. When I go back to that same part, and I'm actually going to use a couple of playing cards, what I can see is that if I cover up the bottom here and I cover up all of the top, and I can just cover that part up with my hand, what I have is a straight line with an angle that's being created of 82 degrees. And here I can use another angle theory that I already know. So this is going to be my corresponding, or sorry, supplementary angles to help me figure out that 180 degrees in my straight line, subtract the 82, is going to leave me with 98 degrees total. When I uncover this again, I can figure out a couple of different ways. I can again use opposite angles now that I know that this is 98 to figure out that this is also 98. Or I can take the fact that if I start here and go all the way around, which is 360, and go 360 minus 82 minus 98 minus 82 more is going to leave me with my 98 degrees. So I've completed and I'm happy with that part of my shape, so I can remove my cards and kind of go from there. And now what I'm going to start using are other angle theories that we've talked about today. So here we can do this a whole bunch of different ways, but again, what I want to do is I want to make sure that I cover up part of my shape just so that it's easier to focus on. I'm only looking at a couple things at a time. Again, I know that I have parallel lines here, and this line is acting as my transversal. So I go back to what we've spoken about today, and I can start to figure out what I need to in terms of calculating those. So if I know that this 82 here, and I always want to try and go back to something that I'm given, all right? I want to figure out one of the angles up in this top little section here. What I chose to do was use the fact that this 82, if I'm using alternate angles, so opposite side of my transversal, but between my parallel lines, is going to be the same measurement as that 82 there. I can continue using a whole bunch of things that I've learned today, or I can go back to what I know and I'm confident from last week, where I've got opposite, and then I can cover up, and I can use supplementary, right? There's a whole bunch of different ways that you can do this, and you're going to have to figure out the way that works best for you. Now, the last thing that I need to figure out is so that I can work down the right-hand side of my shape. Now, again, I'm going to take my playing cards, and I'm going to cover things up, and what you should see is that you have a triangle. So here's my triangle that I've just outlined with my pen, or overlined with my pen, and I know on my triangle I've got 180 degrees total. I can subtract that 82 that I have there. I can subtract that 23 that I have left, and what I'm going to be left with, right, is a measurement in that corner right there of 75 degrees. Once I have that measurement, again, now what I can start to do is start to work down the right-hand side of my shape, keeping some of my stuff covered up. So again, opposite, 75. If I cover up, and I know that 75, I can take supplementary, so 180 minus 75 is going to give me 105 there. And again, I can use opposite to get me a 105 there. Take a minute and figure out the rest of the angles that you have coming down the right-hand side of your shape, and also write in the angle measurements for the angles. All right, so I finished finding my angles, or some of my angles, and what I've identified are the missing amounts here. So angle HBC, got to find that. So HBC is 82. Angle AFC, so I've got to find that one. So AFC, now even though I don't have it written in, it is equal to 75 degrees, and here what I can actually use is interior angles. So again, between my parallel lines, left-hand side of my transversal, and when I take 180 and subtract it from that 105, I'm going to get 75 degrees there. So that's my 75. Angle AGB. So angle AGB, that's what we initially found up there, is also 75. And lastly, angle BGF. So BGF is going to be that 105 that I have right there. Now, yes, it is true that maybe some of you are thinking, oh, I've done a whole bunch of extra work down here, only to find a whole bunch of angles that I actually have written in orange. But the more practice you have with this, the better you will become. Now, if you're finding that you're having a little bit of trouble understanding, maybe go back and watch this video, or also take a look and a read through the examples that are given to you in your workbook on page 146 in the reminder section.